For the following example, solve the system, then give the solutions as a coordinate point. Example 1 wants us to solve the system of equations by graphing 2x minus y equals negative 4 and x minus y equals negative 1. Let's go ahead and change these into slope-intercept form. For this top equation, I'm going to subtract 2x from both sides, and that will give me negative y equals negative 2x minus 4. And I want to now multiply every term by negative 1 so that I get y equals 2x plus 4. And I'm going to plot my y-intercept of 0, 4. So 1, 2, 3, 4. That's going to be up here. Now, normally I would use my slope of 2 or 2 over 1 to go up to right 1 unit, but notice that I'm running out of space, so I'm going to go in the opposite direction, and that should be okay. I could go down to left 1 unit, down to left 1 unit, and then I'm going to go ahead and connect those. And then our other line, I'm going to subtract x from both sides, and if I do that, I get negative y equals negative x minus 1. And if I multiply every term by negative 1, I'd get y equals x plus 1. And that has a y-intercept of 0, 1. And then my slope is 1, so I could go down 1, left 1, down 1, left 1, down 1, left 1. And if I connect those with my ruler, that's going to look something like that. And we know that the two lines are intersecting there at negative 3, negative 2. So our solution for this one is negative 3, negative 2. And I'm just going to go ahead and plug that into both of the original equations just to make sure that we did this correctly. So let's go ahead and plug that into equation 1, or the first equation. So I have 2 times negative 3 minus negative 2. And if I did that correctly, it should be equal to negative 4. So that checks off because this value is the same as that value right there. And now let's plug it into the second equation. So we have our x value minus our y value. And that ends up equaling negative 1, which is the value that we wanted there. So that checks off as well. And that shows that we did this correctly. Example 2 wants us to solve the system of equations by graphing, where we have 2x minus 2y equals negative 4, and x minus y equals negative 1. Once again, I want to change these into slope-intercept form. So in this first equation, I'm going to subtract 2x from both sides. And then I'm going to divide both sides by negative 2. And I'm going to say, I heart algebra. So we end up getting y equals negative 2x divided by 2, negative 2 is x, and then negative 4 divided by negative 2 gives us plus 2. And then this equation, I'm going to subtract x from both sides, and then I'm going to multiply every term by negative 1. What do you notice about these two equations? Take a moment, pause the video. If you said that they have the same slope, you would be correct. Now remember from an earlier video, what does it mean when two lines have the same slope? It means that they are going to be parallel and that they are not going to intersect. So y equals x plus 2 has a y-intercept of 0, 2. And we could go up 1, right 1, up 1, right 1, up 1, right 1, so on and so forth. And so I can go ahead and connect those. And then my second line, it has a y-intercept of 0, 1. And I could go up 1, right 1, up 1, right 1, up 1, right 1, so on and so forth. I can go ahead and connect those. Now notice they have the same slope, so they're not going to intersect. And that means that this has no solution. Let's see what happens if we were to solve this using elimination instead of graphing. So I'm going to go ahead and I'm going to multiply the bottom equation by 2. So if I do that, then my new resulting equation would be 2x minus 2y equals negative 2. And the top equation will not change. So we have 2x minus 2y equals negative 4. Now if I subtract these two equations, 2x minus 2x is 0. Negative 2y minus negative 2y is 0. And then negative 4 minus negative 2 becomes negative 2. So we end up getting 0 equals negative 2. This is not true, and therefore that's what tells us that this has no solution. Example 3 wants us to solve the system of equations by graphing x plus 2y equals negative 1 and negative x plus y equals 3. I'm going to throw on my axes really quickly. So there are my x and y axis. Now I want to convert both of these to slope-intercept form. So I'm going to subtract x on both sides, and I get 2y equals negative x minus 1. And then I'm going to divide both sides by 2, and that's going to give me y equals negative 1/2 x minus 1/2. My second line, I'm going to add x to both sides, and that's going to give me y equals x plus 3. Now I can go ahead and graph both of these. So y equals x plus 3 gives me a y-intercept of 0, 3, and we have a slope of 1. I'm going to go in the opposite direction than we normally go, so I'm going to go down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. Now I'm going to connect those. And let's go ahead and graph the other line. We have y equals negative 1/2 x minus 1/2. So my y-intercept is at 0, negative 1/2. And I could go down 1, right 2, down 1, right 2, and then go ahead and connect those. Okay, so that's going to look something like that, and our point of intersection is happening right there. And notice that this one is not going through a lattice point, or the coordinates are not going to be whole numbers. So let's see. It looks like it's like maybe negative 2.3, comma 0.6 or something like that. That was just a rough estimation, but let's go ahead and we're going to need to solve this using a different method. So this is just an approximation. I now want to utilize a different method. So normally I have to multiply something to one of the equations before I combine them by either adding or subtracting. But in this scenario, I can just add the two equations together as is, because x plus negative x is already going to give me 0, and that's going to eliminate that variable for us. So x plus negative x is 0, 2y plus y is 3y, and then -1 plus 3 is equal to 2. So that becomes 3y equals 2. And then if I divide both sides by 3, I get y is equal to 2/3. And that's actually pretty close to my approximation because 2 divided by 3 is equal to 0.6 repeating. So my approximation was pretty close. Let's go ahead and figure out what the x value is. So I'm going to take that y value and I'm going to plug it into our second equation here. And it doesn't matter, again, which one you plug it into, but I'm going to choose the second one because that one looks like it's a little bit easier to work with. Okay, so I'm going to subtract 2/3 from both sides. And I get -x is equal to 3 minus 2/3. I'm going to change 3 so that it has a denominator of 3. And off to the side here, I'll show you. So if I have 3 and I multiply that by 3/3, that is equivalent to 9/3, or 9/3. So I get 9/3 minus 2/3. And we get -x is equal to 9/3 minus 2/3 is 7/3. And then I just need to divide both sides by -1. And if I do that, I end up getting x equals -7/3. And that's pretty close to -2.3, which was our approximate guess for the x value. So these values are pretty close. So if I want to write my final answer, I want to give it as an ordered pair. So I'm going to say that the x value is -7/3 and my y value is 2/3. And I will box that to be my final answer.